Today we tackle what might be the biggest question. We have with us Dr. Jude Currivan, who's written 2 books, The Holographic Universe and The Story of Gaia, which we actually have right here. So the links are in the description. They're great books. They give a really cohesive and comprehensive arc of how the universe was formed. And the question that they tackle is whether or not our existence is a meaningful and purposeful one. And those are kind of dirty words in science. We don't talk about purpose, we don't talk about meaning, we spend a lot of time talking actually away from that. And Dr. Currivan has spent her life looking at the evidence and seeing something that is very different from the conventional interpretation. And it's not necessarily our interpretation, right? Like, we have had lots of conversations on the podcast about different perspectives on cosmology, about whether the universe didn't have a birth and whether or not the CMB represents the after radiation of the beginning. And there are many people who seem to think that it is not. And those stories seem as valuable as the ones that say that it is. But the question of purpose often does not come up in those stories. And so that's what I really, 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 really enjoyed in this conversation, which is that it is a fundamentally optimistic, hopeful, and aspirational view of us and our place in the cosmos.
Yeah, from an anthropological standpoint, it's a really useful way of looking at the world around us, I think. From a material standpoint, I probably couldn't disagree more, but I kind of held my tongue on a lot of that. I just thought that her perspective was more valuable than me trying to split hairs about the material basis of different atomic phenomena and stuff. So yeah, you can go hear all about that over at our other channel, The Material World. But today, we're checking out cosmology and really the history of cosmology too. So,
and consciousness.
And consciousness and the holographic principle and lots of far out stuff. So I think you guys will really enjoy it.
It ties pretty tightly into Don Hoffman's work. And actually, Don Hoffman was the way that we found Dr. Currivan. And their ideas are very, very much in line with each other. And so if you enjoyed Don Hoffman's conversation, you're going to love this one.
So tell us what you think. Leave a comment. Come over to one of our discussion groups. They're all linked below. Consider maybe supporting the podcast. We really want to expand what we're doing here and be able to take it on the road, be able to do live stream podcasts so that people can share their ideas as we're doing this. But we're going to need some help to do that. So even if you can only give a couple dollars a month, it really adds up en masse. And same with sharing the podcast and getting new people involved in these discussions and helping us find better and better guests. If you do sign up for the Patreon, we just got DemystifySci stickers.
That's upside down, hold on.
Which we will send you if you sign up. And then, of course, you'll come and kick it with us at our weekly chats and help us figure out what to do next, where to go.
Patreon.com/DemystifySci. If you've already signed up for the Patreon, tell a friend, tell your Twitter, tell your Facebook, post an episode, post a clip. We need your help to grow because we've
broken the algorithm, essentially.
We have broken the algorithm, and we are not good at self-promotion. So we are going to depend on you guys to promote us because you love what we do.
All right, folks, enjoy the conversation.
The scientific revolution starts now.
The DemystifySci podcast.
Let us see in the dark.
Aren't you an archaeologist?
My master's degree at Oxford was specialized physics, specializing in quantum physics and cosmology. And my doctorate is in anthropological archaeology, researching ancient cosmologies. So all the order. And between the pieces, I was in international business for 20 odd years. So,
Well, ancient cosmologies, that's so cool. I often wonder how the ancient cosmologies compare to our own. Do you think that there's a thread that binds us to the past in that way, or is our cosmology today completely divorced from the past?
I don't think it is completely divorced at all. And I think there's a lot of commonalities. I think our cosmology in the recent past was pretty divorced from the ancient understanding, because it was a cosmology of materialism and separation. And virtually none of the ancient cosmologies that I've studied or been aware of saw that. Those ancient cosmologies were seeking to bring meaning and purpose and wholeness into their perceptions of themselves and their relationships with each other and wider world. So it's only when we went into the last few hundred years, really, and progressively the last couple of hundred years, that, even with the clues that quantum physics and relativity gave us, we were still really working on a materialist and separation-based cosmology that now is essentially being turned on its head. So what we're now finding in the leading edge science that I write about is finding actually is much more congruent with ancient cosmologies and universal wisdom teachings and indigenous wisdom teachings, but it also takes it forward. I'm not sort of saying that, 3,000 years ago, our perspective of the universe was as advanced as ours is, because we have the technologies to look deeper, look further, than we've ever been able to before. So I think as Isaac Newton said, I do feel that we stand on the shoulders of giants, and those giants go back into, that those ancient perspectives. But I also feel we're on the threshold now that we are seeing the evidence that is coherent and congruent with those perspectives, but a deeper and higher and greater degree. I do feel we have an opportunity now to evolve our consciousness by that deeper perspective. So this is really a sort of an integration of science and spirituality, and it's a transcendent perspective, because it's bringing the both of and, getting into a much deeper sense of unified reality.
And when you were originally more on the anthropological, or I guess you started out, did you do your PhD first and then the physics later?
No,
Okay.
I did my master's as undergrad at Oxford, and then after 20 odd years in business and other scenic route variations, I did my PhD in the early 2000s.
I see. Yeah, so was it the physics that led you back to the more consciousness-oriented ideas, or the more anthropological oriented ideas? Were you unsatisfied with the physics explanations for the cosmology, and that led you to the studying the ancient history, or was it all kind of happening at once? What was that like for you?
I've never been satisfied by the physics depiction, because, as a quantum physicist, I know that the only way that quantum physics can work at all is for our universe to be non-locally connected as a unified entity. And so I go back to when I was 4 years old, because when I was 4 years old, I was starting to have what we might call supernormal experiences, out-of-body experiences, precognitive experience, telepathic, lots of intuitions, synchronicities, all the. So I was walking between worlds from a very early age. So for me, it was that, if you like, metaphysics, that perspective of a much greater expanded view of, if you like, cosmic consciousness, universal consciousness, my own consciousness, that then when I was 18 got me to Oxford to say, well, okay. And I was absolutely fascinated by quantum physics when I was a child, and the stars and all of that. I really was looking for as good an explanation as the leading teaching at that time could offer me of the how for what I was experiencing, became our physical universe. And I was very disappointed.
Yeah, I bet.
I was really, really disappointed. So the last sort of 60 years has been that ongoing search for that deeper understanding with the evidence to support it. And for me, coming from a perspective that mind and consciousness aren't what we have, they're what we in the whole world are, which was the ancient Vedic perspective of ancient India and many other wisdom teachings, spiritual teachings. So it wasn't that I was looking for the evidence to prove that, because if the evidence was not showing that, I hope I'm a good enough scientist to follow where the evidence leads. But I have to say the evidence is leading ever more to that remembered perspective of the unified nature of reality.
Do you remember the moment when you realized that physics wasn't going to give you the answers, or was that a discrete event that occurred for you?
Yes and no. When I was at Oxford, pretty much yes. I mean, from the first term, it was clear. And the first year at Oxford was all mathematics. So the first year, started off with the Schrödinger equation and all the quantum physics, mathematics. I'd already been doing some of that anyway, pre-advance of being taught it. I was so interested, I was doing it on my own anyway. And also, studying the, realizing, I mean, this is a realization that Einsteinian space-time invariance coming off from space relativity and time relativity actually is based on Pythagoras. So that without Pythagoras and the understanding of a right-angled triangle, you can actually expand that into Hilbert space and you come up with E equals mc squared. So what I was realizing, that was useful, because what I was realizing then is my understanding of multidimensionality for our universe became three-dimensional space, or the appearance of three-dimensional space, with three-dimensional space needing to be orthogonal. In other words, the X, Y, Z axes, because without that and a flat universe, which we now know is the case, you don't get to E equals mc squared. So there was a beautiful sort of track back. And I wasn't taught that, by the way, at university. I came to understand that and then see how that works, and tracks back to Pythagoras. So that ancient wisdom was very present and is very present in our understanding now, as is so much else.
Do you have any sense of the cosmology of Pythagoras and his cult and how that relates to our cosmology today? Is there a direct line between those two?
There's a scenic route between those two.
Yeah.
but I do feel there is indeed a route, because of course Pythagoras, Euclid, Plato, the Greek philosophers were also geometers. And with the most simple of equipment, a sort of straight edge and something to write with, and an ability to connect 2 points, they perceived our universe as being innately geometric. And of course, more recently, very recently, and really only when computers allowed for the analysis of vast amounts of data, did people like Benoit Mandelbrot, who was studying coastlines, etc., realize that there were geometric relationships in what we might call the natural world, which I'd rather not call because it separates us from it, but that essentially the world is indeed innately geometric, so innately relational. It's just that the idealized geometries, the Platonic solids, the 5 Platonic solids, which are the only ability to have that idealized geometry in three-dimensional space, are fractal, in the sense that they are fragmented dimensional geometries that tell us so much about the informational patterns within and throughout the natural world, from atoms through to the whole of space. So there is that line, but instead of those idealized geometries, for example, a triangle is the asymptotic end point of fractals that are geometrically based on triangular relationships.
Yeah, it's incredible that you can derive cycles mathematics from a triangle, essentially. Like all of the same trigonometry is used to describe cyclic behavior, which is, of course, absolutely essential to atomics and electromagnetism and light.
Resonance.
Perhaps everything.
Yeah.
Well, the quadrivium, the curriculum, the quadrivium, as it came to be called, is sort of a universal reality based on number. And, number in space is geometry, and number in time is music. So hence the resonance, the harmonics, all the rest of it. So when we now, not just cosmologically, but at all scales of existence, are realizing that numerical, as it were, that mathematical underpinning that then embodies meaningfully in formation, expressed as all of these wonderful patterns in space and time.
There's a certain amount of determinism there, I think, where the model of a universe that is filled with these nearly invariant geometric relationships unfolds in a deterministic way because it can only go according to these relationships and how they will fit together. Do you see your philosophy as being deterministic?
In that regard, yes. Insofar that if we go back 13.8 billion years to the first moment of our universe, of energy, matter, space, time, or its appearance, then the laws of physics are essentially algorithms that enable those incredible relational dynamics to be embedded within the very fabric of our universe. And there's not just that, but they are so exquisitely fine-tuned. The constants, the basic constants of our universe are so exquisitely fine-tuned. The Planck scale measures are the sort of pixelation measures of universal reality. So we have everything there that enables our universe not just to meaningfully exist, but to purposefully evolve from simplicity to ever greater levels of complexity and individuated self-awareness. Deterministic in the sense that the laws of physics are the laws of physics, probably through our entire universal life cycle, which we can certainly explore what's now emerging to underpin and frame that. But, we are now standing, as we speak, on the bow wave of our universe. The past is the past. There is a causality stream within space-time that's brought us to this point. But, one of the problems with the block paradigm is that the sort of this sense of determinism going into the future as what might unfold in consciousness rather than what will unfold, because the laws of physics, are there for the whole of the life cycle. But what they're allowing is from that foundational simplicity for ever greater levels of complexity to emerge, to be experienced and to emerge. And that of itself, I would say, is not deterministic as the way that manifestation. I would say that is not deterministic.
So there's like a degree of choice that remains there at the end of the day, essentially.
And there's also chaos, right? Where it's like, even if there isn't necessarily choice, there's the chaos will make it so that there appears to be choice.
Well, except that chaos is very misunderstood. And, that's why chaos theory is no longer named chaos theory, but complexity theory. And why, when we look at the appearance of randomness and chaos, we now have evidence that I've written about in the Cosmic Hologram and the Story of Gaia, that it's hiding underlying order, underlying meaning. So, there's obviously processes where that dynamic relationality, breaks down into more what we might call chaos. But even then, there are islands of coherence that then rebuild into that ongoing evolutionary impulse that continues its process from simplicity to complexity.
Yeah, it's interesting how the ancients essentially came up with this idea of cosmos and chaos as a duality, and it really just comes down to what we understand patterns in versus things that we don't yet understand the patterns in. So I really appreciate that delineation, because chaos is always subject to unfolding into order and becoming part of the cosmos.
Exactly. And, given that, the what I'm writing about is the evidence, it's not just the theoretical framework, which I also offer, as a result of, expanding and reterming laws of thermodynamics as laws of information or infodynamics. It is this process, as you say, that ebbs and flows, but underlying everything, because on this premise, everything we call the appearance of our universe, it's energy, matter, it's space-time, actually emerges from deeper levels of non-physical causation and as meaningful in hyphen formation, and working with the holographic principle, holographically manifested. And, I write a lot about how that evidence for that is present at all scales of existence and, across many fields of research, including the study of collective human behaviors, which is why perhaps we can get over this, the natural world out there and us here, and also that inner-outer delineation, and really soften that and really, feel into that remembrance of relationality.
Can you? I'm sorry. I just really want you to explain this non-physical causation business before we get past that, because that's a.
And I was going to ask the exact same thing.
Cool.
Like, we come from a particularly, I don't want to say materialist, because then it bends you into the group of materialism, and I don't necessarily feel any kinship to the materialists as a movement. But when it comes to something like science, I think that the way that we've jury-rigged this for ourselves is that physics is the study of things interacting. It's a materialist discipline. And then... And say it one more time?
Happy with that.
Okay. And then there's biology, which is very much not a materialist discipline.
Disagree with that.
Okay. All right.
Yeah, I guess we just have to understand what we mean by physical
and non-physical causality. Yeah. So let's just unpack this stuff for a little bit, because it's there's a lot here.
Happy to. Well, first of all, as well as I do, that when we dig down into the sort of tinier and tinier aspects of our universe, what we call physicality is actually much more ephemeral and much lighter, in the sense that, when we dig down to atomic scales and smaller, we're realizing, and this is why quantum field theory succeeded that earlier, more mechanistic perspective of atomic structure, is that what we find is that there's 99.129s after the decimal point percentage of no thingness. And what actually remains is more the sort of interrelationships of what we call fields. But what are fields? Because what we now have the evidence for is that the perception of energy matter is that energy matter is actually information expressed as what we call energy matter. And it doesn't mean that it's not real. It just means that quantization and the harmonics and the resonances that are imbued within energy matter are perfect ways of expressing consciousness. And I don't just mean human consciousness here. I'm talking about universality here. Sir James Jeans, the Edwardian scientist and philosopher, talked about our universe being more a great thought than a great thing. Max Planck had the same view of consciousness being primary, as did Einstein, as did many others. So what I'm talking about now is not that energy, matter, and space-time are not real. They are the appearance of our universe. I'm saying that when we go beneath that to understand the hows of that appearance, we need to go to non-physical realms, which is why, if you look at the Schrödinger equation, and in fact, all of the quantum equations, mathematics, are complex mathematics. In other words, they have what we call real numbers, and they have what we call imaginary numbers. And the imaginary numbers come from this concept of phase space. But if you actually speak to most many cosmologists now, they're realizing that phase space is where the levels of causation that then arise as the appearance of our universe actually happen. It's like phase space is the sort of the boundary, as it were, of cosmic mind and cosmic intelligence, creating a universe or our universe. So that's what I mean. And when we ally that, which we can talk about, to the holographic principle, we can see more clearly how that happens.
My first question is, what do you mean by consciousness? Is that self-awareness, or is it something, a more elaborate concept than that? What is your definition for consciousness?
There are three of us here. We could probably come up with at least 6 definitions of consciousness.
Well, I just think it's important because I don't understand how to understand how there's thoughts without a thinker, and so I feel like if I understand,
I'm being facetious. It's just that there's always this perspective that if you get 3 people in a room, there'll be 6 definitions of consciousness. I am guided by my clarity on consciousness and mind by my dear friend Professor Max Velmans, who is a seminal writer. And Max talks about reflexive monism. And he talks about mind as being the, whether it's cosmic mind or mind per se, as being the ground of being. And then, as you say, that consciousness is a self-awareness of mind. So I don't just use the word consciousness. I do say that mind and consciousness aren't what we have. They're literally what we in the whole world are. Because I don't want to get into the parsing of consciousness, what levels of self-consciousness, what levels of subliminality, whatever, and the realization of, as Einstein would say, cosmic mind is all pervasive in the appearance of our universe. And as Max Planck would say, consciousness, in other words, there is a self-awareness for our whole universe to be able to exist and evolve as a non-locally unified entity. And that, I would suggest, is what this evidence at all scales and many fields of research are now showing. And the way they're showing us is it enables us to transcend what I was frustrated about 60 years ago, to come with an integral model that can be absolutely founded on mind, cosmic mind and consciousness, and show a howness from that perspective into a universe.
I mean, I think that this makes sense because you often will run up against the criticism that, look, you can't explain the universe with you can't explain stuff with just stuff. Like you end up in a position where somebody has to ask, like, well, why does it organize into the most fundamental unit of the stuff? Exactly. And as soon as you start to ask that question, then you have to create another frame to put the stuff into. And it seems like this is what this like phase space relationship that lies outside of the real is.
Absolutely. And phase space is as real. And I think our languaging, it's really interesting to me as a linguist as well, how our languaging around this is in an emergent process. Because, when I was growing up and I was fascinated by quantum physics and astronomy and all the rest of it when I was very young, as well as ancient wisdom. But I now see that, quantum's become a brand, quantum shampoo. I mean, it literally is. And yet I would say that quantum is so last century, because all the work that's been done really for the last 20 odd years has been moving on from consciousness, not to on from quantum physics, not to throw it out, but just as quantum physics and relativity physics emerged and included and transcended Newtonian physics, now informational physics, and it has to be metaphysics because of this underlying causation into the physicality of what we call our universe. It's a sort of an informational metaphysics of mind and consciousness. So we are expressing itself in complementary ways as quantized energy, matter, and as entropic space-time. So our languaging needs to be, or will naturally continue to, I think, evolve and emerge as this ever more compelling evidence is revealing a much grander sense of the nature of reality that is essentially multidimensional reality.
Is this an antenna theory? Is the idea that there is the pervasive consciousness which is infusing the material with animus, with
a vital force?
Yeah, is it a vitalism of sorts?
It's more than that. It's actually more than that, because it's almost like you're saying, well, there's consciousness or mind, and somehow it's touching what we call physical. It is physical reality. This is the point, and this is where our languaging is so emergent. I mean, the early quantum physicists, most of them, as you probably know, were finding things that completely upended their whole mechanistic perspective of the nature of our universe. And to get some deeper insight into what they were actually discovering, a lot of them went back to the Vedic tradition of ancient India and the Upanishads. And the Ishnavaya Upanishad, perhaps the most profound, says exactly what, says what I'm saying, that mind and consciousness aren't what we have, they're literally what we in the whole world are. But now, of course, we're thousands of years further on at the leading edge of this deeper realization. So I'm not suggesting we go back, I'm suggesting that we bring forward that insight, those insights, but then they are the giants on whose shoulders we stand. So take them forward. How do we do that?
So the way that I'm starting to wrap my head around this is that when you look at the early 20th century evolution into quantum, you had a spookiness that was suddenly introduced into the machine, right? So even the early models of the atom, right? There are these little particles that are spinning around these other little objects that are at the center. They're orbiting just like the planets, and there was the sense of a discreteness. And then that shifts to this idea that, well, there's not actually really a discreteness. Everything's smeary, and there's waves and probabilities, and it starts to go into this direction of being much less separated. And it seems like the direction that you're pushing it into now is to say that, look, what consciousness, if I'm understanding correctly, is that you define consciousness as the material as all of the material and the relationships between itself. It's like the summation of both.
Yeah, it's an and. And, they understood, the quantum physicists understood from the get-go that what they were discovering was an essential inseparability. And for quantum physics to work at all, that inseparability, that non-local Einstein spooky action at a distance, was the deeper nature of reality, that our entire universe exists and evolves as a non-locally unified entity. And, of course, Bell came up with this sort of, this way of seeing this. And two things to add to that. In 2018, researchers at MIT non-locally entangled photons of light in the lab with starlight from 600 light years away from quasar light 12.2 billion light years away. So we have this coming together of this cosmological scale to show the evidence for such non-locality. And of course, this year we have 3 physicists winning the Nobel Prize, all of whom have expanded on an experimental basis the space-time non-local entanglement of the world. And it's not an either-or, because what Einstein was discovering was the relativity of space and time. He was discovering that within space-time there's a cosmic speed limit, which is the speed of light, without which we could not go back to the origin of the universe and say it was 13.8 billion years ago. We wouldn't have an arrow of causality. We wouldn't be here having this conversation. I think the difficulty was the perception it was an either or, and it's an and. Within space-time, everything, our entire universe is non-locally unified, But within space-time, its manifestation embodies causality, embodies space-time as invariant to enable the algorithms that are the laws of physics to play their way through a life cycle of our universe. And yet, just as a balloon blowing up, the entirety of our universe knows itself for its entire journey, its entire evolutionary journey and life cycle. So it's an and.
I want to get into this idea of the universe knowing itself, but before we go there, I want to talk about the Bell's inequality and the quantum entanglement, because we had a really, really fascinating conversation with Carver Mead, who is an emeritus professor from MIT. Caltech, you're absolutely correct. And he was an electrical engineer. He worked in the semiconductor industry, and then towards the later part of his career, he worked with, I think, John Kramer, and they wrote a book called Collective Electrodynamics, and they picked up on a thread that had been around at the turn of the 20th century, but had been left behind with all of the exuberance of like spookiness, where they explain entanglement as being far more straightforward than we think of it. It's literally just the atoms being connected. Like the atoms are connected. There's like and you don't need to have a mysterious thing of how is it that the quasar light is entangled with this photon on Earth. It's like,
it's essentially a nodal situation, right?
Of course it is. Everything's relational, but it's relational on a universal scale. Absolutely. Don't have an issue with that. But you need to bring that into, at the same time, this phase space underpinning, which we know is the causal directive because of the attractors that underpin the appearance of complexity. So the thing is, you can't just take one piece of this wholeness. You have to bring all of it together. And when you do that, it all hangs together beautifully.
And that's something that, so one of the projects that we have is we're trying to create like a material interpretation of the equations of quantum. And I've always been of the opinion that the math is the place where you have to start because the math works.
It describes reality.
That's what I mean. Like, it describes reality really effectively. And so because it describes it, if you can understand what the math is telling you, then you can imagine what it looks like. And I've always been troubled by the imaginary numbers. And this is the first time that I have a sense of I mean, I don't want to say that I understand it, but I at least have a direction in which to start thinking about what those numbers represent.
Yeah. And of course, we've not given ourselves any leeway on this because we call them imaginary. And they're not imaginary. They're absolutely vital because they're the bridge point. They're the bridging to what is manifested in what we would call our physicalized reality and the underpinning of it and the causality of it. And they do so. And this is why, instead of energy, matter and space time, which is marvelous, and to understand why energy matter is quantized, why space-time is entropic, and bring all that together and then see that as an emergent appearance of our universe enables us to have this. I mean, the other point to make, there's a book just out by Professors Brian Cox and Jeff Forshaw that came out in October on black holes, and we can certainly talk about black holes and how they and the study of black hole thermodynamics was expanded to the holographic principle and for me, infodynamics. But, they end the book, and these are both professors, quantum physics, astrophysics at the University of Manchester in the UK, saying basically in their perception, the universe, they don't use quite these words, but is a cosmic hologram, which was the title of my book 6 years ago. Because they realize, and more cosmologists are now realizing exactly this, that the appearance of our universe is not its deeper fundamental reality. And so they're sort of saying, as more and more cosmologists are, and scientists generally are, that the appearance of our universe does emerge from these deeper, non-physicalized, if that's the terminology we want to use, but nonetheless part of a piano keyboard of consciousness, into the appearance of our universe. They don't know where that slippery slope will take them, but they're brave enough, they're courageous enough to say, look, this is what the evidence is showing. We don't really know what it means, because most, certainly physicists, don't go anywhere near consciousness. And I know you made the point earlier about biology and physics. I really want us to sort of move into that, because, again, it's not an either or, it's an and. Because what we're finding is this reality, this understanding, is at every scale, all scales of existence, from the Planck scale to the entire universe and everything between.
Can you elaborate on that?
Yeah. Well, first of all, let's talk about the Planck scale, perhaps, because there are 5 constants, physicalized constants, that are identified as Planck constants. The Planck scale is almost the scale of pixelation of our universal reality. And the 5 measures are measures of mass, energy, space and time, and temperature. So my curiosity is, why are there 5 Planck constants? No more, no less. And the view would be that any self-aware species that's got to our point of technology, or in other ways of knowing, would actually come across this perception of the basic appearance of our universe, its energy, its matter, its space, its time, its temperature, as being founded on a fundamental measure. And so what we now understand is both what those fundamental measures are about and why there are only 5 of them. And they're about because they represent, you know, in sort of, for example, in space-time, the Planck measure of length is around 10 to the minus 35 meters. The Planck measure of time is around 10 to the minus 44 seconds. That is the level at which our universe's reality comes into its appearance. When we talk about energy and matter, it's the same, and it's all related to light. And the Planck temperature is the temperature of the hottest temperature of our universe's origin. And that temperature is inversely proportional to the entropy of our universe. So we can bring all of that together when I mentioned earlier about expanding the 3 laws of thermodynamics to 3 laws of infodynamics. And I don't want to bang on because but if you'd like me to explain how that all hangs together, I'd be delighted to. But it gives us a reason why there are those 5 Planck constants and why they are the fundamental measures of our universe's existence and reality and ability to evolve.
I mean, I think it's interesting. So I think it's worth unpacking where Planck's... So all of these constants are derived from the behavior of light, in particular studying black body radiation. And Planck's constant essentially emerged in order to scale the energy with respect to frequency of light. And so, you know, my PhD is in material science, and I see these harmonic situations as indicating something about the material properties of the atoms when they're undergoing these transitions and these conversations that we call light. So why do you think that, all right, since all of this information comes down to the way that these bodies behave with respect to light, why do you think that they're different constants as opposed to really just being different instances of this fundamental energy frequency scaling metric?
Because we've tried to sort of reconcile quantum physics with relativity physics for 100 years. And the whole push for quantum gravity, I think, misunderstands the basic nature of universal reality. If you go back a step to something that was even there before the quantum physics and relativity physics of early 20th century, we have 3 laws, originally 2 laws, but 3 laws of thermodynamics. And the first law of thermodynamics talks about how an enclosed system or a containered system, the energy can change, but it can't increase or decrease through time. So if we take our universe and go back 13.8 billion years to its beginning, as I talk about, not in the Big Bang, but as the first moment of an ongoing big breath, because of its level of fine-tuning and orderedness, enabling it to exist and evolve, then we've got a first law of thermodynamics that can be restated. We can talk about, instead of a closed system or a container system, we can talk about our entire universe. We can talk about not just energy, but energy matter because of the equivalence through E equals mc squared. We can talk about, the compelling cosmological evidence as ours is a finite universe. So we can start to get our heads around this idea of a life cycle of a universe, where the first law of thermodynamics is actually describing energy matter. So also, if we go through all the other evidence that's showing that information, meaningful information, is the relational patterning, processing flows that are more fundamental than the appearance of our universe, but that are embodied as the appearance of our universe, then the first law of thermodynamics can be actually expanded to a first law of infodynamics, which then says that information expressed as the quantized energy matter of our entire universe can change, but it can't be created or destroyed through the whole life cycle of our universe. So that's showing, and that's probably the simplest description we could have of quantum physics. And that's the first law, okay? The second law of thermodynamics says that the entropy of a closed system can only increase through time, okay? Again, for our universe to be a containered system, go back 13.8 billion years, its entropy was the lowest it has ever been, which is why it's increased ever since. And this is Brian Greene's basic thesis. And we've got the evidence to really show this. But the point is now, when we say time, we cannot separate time from space. That's one of Einstein's greatest perceptions. So what we've now got, an information expressed in a complementary way as space-time. So we now have the second law as information expressed as the entropy of space-time can only increase through time, of our universe can only increase through time. But the issue then is we've not gone far enough, because we've still defined entropy as the microstates, the energetic microstates of a system, instead of now realizing that the entropy is the informational content of such a contained system, which is what people like Vladko Vedral and other quantum physicists, quantum information physicists are now appreciating. So this is now saying, rather than entropy as energetic microstates, let's talk about entropy, I-N-tropy, as the informational content. So now we have the information expressed as the entropy of the space-time of our universe can only increase through time. That is the simplest description of relativity theory, and it explains how our universe can evolve. So the first two of those restated laws, from thermodynamics to infodynamics, one give us a really simple basis for quantum physics in energy matter. Secondly, give us a really simple basis for entropic space-time. But then you need the third law of thermodynamics to complete the box, tie the red ribbon on it and share it. The third law of thermodynamics says two things: that a contained system, well, in quantum terms, that a contained system can never go below absolute zero, or in quantum terms approaching it. But it also says that the entropy of a container system is inversely proportional to its temperature. Now, what we've done in those first two laws expanded entropy to entropy. So at the very beginning of our universe, when it came into being 13.8 billion years ago, it came into being at its lowest entropy and its highest temperature, which was its Planck scale temperature. So the cycle of our universe, as space has expanded ever since and time has flowed forward, the temperature of our universe has fallen as its entropic informational content has increased. So beginning at 10 to the 32 K, which is a Planck temperature at that first moment, we're now just over 2.7 degrees, which, with all a huge amount of other evidence, suggests that our universe is running up in terms of its embodied mind, consciousness, meaningful information, experience, evolution from simplicity to complexity, as its temperature is running down. And that then can help us understand the life cycle and the how of our universe from that first moment of a big breath to the end. And the final piece is the holographic principle, which I'm going to take a breath because I'm sure you've got loads of questions.
Okay, I mean,
and now we can bring that in.
Yeah, let's unpack that.
I really like this because it basically folds the ship of Theseus into physics, where it's like, yo, it's not just a ship, like it's an idea as well, and you can replace all the planks, and the way that you organize the planks is still what makes the ship. And that's something that has long been missing, which is that it's not just the objects, it's the relationships between them. And that's what information in your definition seems to mean, which is that it is not just all of these things bumping around in the dark that you have to consider. You also have to consider how the relationships between them evolve, persist, and affect the future. Is that an accurate read? Okay.
Absolutely, because that's the whole journey from that initial simplicity. It's from protons to what I call, planets and plants and people. That's the journey of ever greater complexity. And that is all about all-pervasive, meaningful information and the patterns and the processes.
It's the why.
Flow.
It's the why.
It's the why. It's the why and it's the how.
So let me get this straight. So the entropy of the universe is increasing, is that correct?
Yeah. It's always been increasing from that first moment 13.8 billion years ago. But the point is that instead of entropy, as Boltzmann, of course, did, speaking to the microstates, the energetic microstates of a system, we're now understanding that, a more expansive perspective is that information, which expresses itself as energy matter, but the informational content of a system is a deeper perspective of what we've called entropy, but which we can now name entropy. And because it's meaningful information throughout the whole enchilada, this is our universe, it's in with a hyphen, with a dash in formation. So absolutely.
How do life forms fit into that? Because do life forms, we generally think of them as restricting or let's say lowering the entropy of the molecules involved because they can't, they're part of you, let's say.
This is a profound misunderstanding. This is part of that profound misunderstanding between, a perspective that entropy is about order to disorder, and therefore biologically living systems or any open subsystems, because they are coherent, somehow are reversing entropy. And names like negentropy and syntropy have come into that perspective. We need to just go back to basics on this. Boltzmann never talked about entropy as being from order to disorder. He talked about entropy as a measure of the energetic microstates of a system. So if you think, for example, just as an example, but a pack of cards, okay, playing cards. You open a pack of playing cards, you do on the polythene wrap, and they're in order. They're in order of suites, they're in order of number, they're ordered. Throw them up in the air, they'll land all over the place. Collect them together, they're in more states than that initial order. It's not that they're in disorder, that they're representing more states because there's more relationships. So you do it again, and there's still more relationships. Yeah. So that's the point of entropy. It's an increase in the energetic microstates of a system throughout time. Now we're talking about our entire universe and everything in it partaking of that journey from the lowest level of entropy to ever greater levels of informational content, i.e. entropy, as we go through time. What happens with any subsets of our universe where there is a temperature difference between that subsystem, yeah, whether it's a planet or a person, where there is a difference in temperature, then that is a measure itself of the amount of entropy that can continue to be embodied by that system. So with our planet, we both have the internal heat coming from the radioactive and the churning of our core, and also the tidal heat that's created by lunar. And we also have obviously the heat coming from Sol. So we have a throughput of energy throughout our entire planetary home. Yeah. And many, millions, hundreds of millions of years ago, one biological organism perfected oxygenator photosynthesis to take that energy and to use it in a more effective way than had hitherto been, to continue that process of sustaining a temperature difference between a biological organism and its ambient environment. But of course, then we have the ambient environment and the organisms being part of a planetary ambience that of itself has a temperature difference and therefore an entropic difference between itself and outer space. And we have an entire universe where we have these subsystems which are open in themselves, whereas our entire universe is contained, but their openness allows that throughput of information that we talk of as expressed as energy. And so, but they're all part of an entire universe whose overall entropy is inevitably increasing moment by moment by moment, Planck moment by Planck moment by Planck moment. So when we're born, for example, we're born with this entropic potential. We're born as part of a subsystem that has a temperature difference between our environment, and that throughput of informational energy is our lifetime, and is our contribution to a universe that's always increasing its entropic informational content. So it's not about reversing entropy at all. It's just been part of our universal's continuing increase of entropy for this level of our incarnational lifetime. When our physical bodies die, our temperature inevitably then drops to the ambient environment, yeah? But it then gets composted, recycled, but always part of our planetary home's ongoing entropic existence and evolution, which is part then, because of the non-locality of universal unification, is part of that mind consciousness of our entire universe. So these concepts of negentropy and syntropy are just mistakenly based on a perception of order to disorder, where it's not. It's that ever-increasing informational content.
And they sort of mistake the fact that entities are separated from one another fundamentally.
Exactly.
Right?
Exactly.
Because if you look at the amount of, just from like the chaos analogy that I'm familiar with, like if you just look at the amount of chaos that a life, like turn a child loose in a very well put together studio, for instance, life forms have an amazing way of just like tearing up their environments and actually creating all sorts of chaos. And if you like see them as separate entities, then it gets confusing. But I think the key there is the open system, really, when it comes.
The open system. Yeah, the open system. And even, people like Prigogoni and David Bohm, and bless them, I mean, my goodness me, they were giants on whose shoulders we stand. But they didn't have the understanding, that I'm talking about now. They didn't have the evidence. But exactly that, as an open system, as an open subsystem, because we can only understand this in totality as a universal process, then it makes eminent sense. And that temperature difference is so simple. It is that ability of that particular organism or subsystem to continue to have entropic potentiality.
Can you take us into the holographic principle and how this is this an idea? Yeah, I'm going to let you explain it actually before I mess it up.
You're not going to mess it up at all, but be happy to. I mean, what I on a personal level, this is such a sad story, I have to tell you. But on a personal level, when I was 19 and I was at Oxford, I had a wonderful mentor called Dennis Sharma. And Dennis Sharma had been Stephen Hawking's mentor when they were both at Cambridge. And then Dennis came over to Oxford and took me under his wing. And he always loved mavericks. I can't imagine why. I can't imagine why I thought Stephen was one and I was another. But he took me under his wing. And in my second year, was it my second year? Might have been my first. No, it was second. He invited Stephen Hawking and Roger Penrose to come to Oxford to give a postgraduate, the physics postgraduate community, a presentation on black holes. And so they came along, and Dennis invited me to go along there, and I did. And I was the youngest person in the room. And you can imagine how many women were there at that time. But it was extraordinary, and it really fired something in me because I had this intuitive sense that the understanding of black holes would be absolutely fundamental to our greater understanding of the nature of our universal reality. And Dennis said to me, Jude, there's a university essay prize going at the moment. Would you like to put a submission in? And so I did, and I wrote an essay on black holes. This was 1972. And I won the prize. Yay! Which was all of, I think you'd say the equivalent of about $35 now. But in those days, it was a lot of money. Kept me in beer for weeks. But the point is that, we've come, it's like I've come full circle now, because the study of the thermodynamics of black holes, which has been a very active research topic, including for Stephen, when he was with us, and many others, had a basic conundrum. Because what the question was is, when a large star, when a massive star collapses, such that its gravitational collapse is so powerful that it can't be stopped, and it falls inside what we call an event horizon, which is the point on its spherical, because of course spherical star, spherical event horizon. When it goes beneath that, not even light can escape. I know there's a slight nuance on that, but not even light can escape. So it becomes what we call a black hole. And the conundrum was, what happens to the information of that star? And if the information that had been that star was lost, then the whole of quantum mechanics would be thrown out the window. We'd have to find something else to do with our time. But the understanding was that, and Stephen was very, very significant in this perspective, is that the information actually was held on the event horizon. But the other thing, which was very counterintuitive, was if that 3D spherical star, that information presumably would be proportional to the three-dimensionality within that spherical event horizon. And it's not. It's proportional to its two-dimensional surface area. And that, of course, goes, the light bulb goes off on various folks' head. Because in a hologram, what happens in a human technological hologram, we shine a beam of light, we split the beam of light, and that split light, one aspect of it, one part of it, is shone on an object, a 3D object, bounce back and collects all sorts of information, the information of the appearance of that 3D object. It then is combined with the original beam onto a two-dimensional surface. So that pattern of information is held on a 2D surface. When we shine further light through that 2D surface, the holographic projection of that original 3D object is projected as a hologram. The point of the hologram is that the entirety is held within every pixel. So it's back to the old Hermetic tradition of as above, so below, as without, so within. So the technological characteristics of a hologram are that wholeness represented in every pixel. Yeah. So when we looked at black holes and the nature of their information, it was like, this is like a hologram. So people like Susskind and 't Hooft and others expanded that perception from a black hole to the whole of our universe. And what's called the holographic principle hypothesizes that the appearance of our universe is a holographic projection into a 3D appearance of space and a 1D perception of time, so 4D space-time, from a 2D boundary to what we call the boundary of our universe, the boundary of space-time. And the work that people like Jacob Bekenstein did also showed us that that surface area holographic informational and therefore thermodynamic understanding of black holes was pixelated in triangular surface areas at the Planck scale. So the holographic principle now connects us with the Planck scale, the understanding of the thermodynamics, which we've expanded now to the infodynamics of our entire universe, with our universe being a holographic informational projection from a 2D space-time boundary into a 4D space-time appearance. And that basically is the last piece in the Rubik cube of all that we've been sharing tonight, because that shows how information at that phase space realm of causation, and I'm simplifying here, but can actually then be projected as the reality of our universe, but a reality that is non-locally unified, and yet can exist and also exists and evolves as such a unified entity, meaningfully existing and purposefully evolving, because that first moment of space-time, that first moment of our universe was so incredibly ordered and fine-tuned, and with the algorithms of physics, that deep relational perspective enabled our universe to evolve. So the first law of infodynamics, now informationally as quantized energy matter, shows how our universe exists. And the second law of infodynamics, with the entropy of space-time, shows how our universe, and the relativity of space-time, shows how our universe evolves. So this also offers us pointers to how we might reconcile quantum physics and relativity physics by going to that deeper, more fundamental awareness. And then the third law fits in as an adiabatic life cycle of temperature and informational content of our system. And of course, everything within it, including all of biological evolution, is naturally held within this new narrative, within this unitive narrative.
Something just struck me about you mentioned that at the Planck length, there's a triangular geometry, which is really interesting to me because triangular geometry can also represent cycles as well.
Absolutely.
And it's just fascinating to me to think that at some fundamental scale, at the like basic fibers of material existence, that there's some sort of cyclic motion which might be embedded in that. We talked to Julian Barber on the show a while back, and we were trying desperately to make sense of his idea of...
Because he begins with a triangle, and we never really got to the bottom of why he picked triangle.
Yeah, but it kind of... It occurs to me that the cyclic nature of triangular geometry could offer a clue.
Mm-hmm. Well, I agree. And I think the other thing to note is that a triangle is the simplest of or a triangle, a tetrahedron is the most simplest of the Platonic solids. So what I've tracked through all the cosmic hologram and the story of Gaia is really paraphrasing Einstein, that our universe is as simple as it could be, but no simpler. And I've just added to undertake its evolutionary purpose, or to embody its evolutionary purpose. So triangles and tetrahedra are absolutely the simplest in 2D and 3D of that perspective. And of course, because they are idealized geometric structures, their relational dynamism, again, is its simplest and it's in its most perfect. I think the other thing, going back to what we were saying earlier about universal wisdom teachings, is the significance of trinities, throughout so many traditions, and you get in the Vedic tradition, you get, this is not gendered and this is not human per se, but it's embodied in us, we can suggest, is this sense of the divine feminine, the divine masculine, the Ida, the Pingala, but also the divine child, the Shushumna. So you have the I Ching also saying the beginning is one, not was, but is one. The one becomes two, the two, three, hence that threefold relationship. And then from the three, 10,000 things are born. So I think this is really fundamental. And of course, in the Fibonacci sequence, we get 0, 1, 1, 2, 3. And then 5, 8 and onwards. So there's a huge amount, you were saying earlier about resonance and harmonics. There's a huge amount by which this threefold relationship embodies the innate harmonic resonant nature of our universe. The other thing to finalize on is the golden mean, where we split a string or a length into two, but the two are essentially three in their relationship. Yeah. Mm-hmm. So I think there's a really good point here. The only thing I would say is it also plays out through spirals. It's this spiraling of simplicity to complexity, because what we get this as an underpinning is at all scales of existence. We get it at quarks. We get it at atoms. More and more and more as we go through this, it's the natural, relational and stability, but also evolutionary potential for the whole universe.
We have the symmetry of 3 on the level of atoms and quarks, you were saying?
Well, just like the spiraling helical nature of the angular momentum of different particles.
Because I couldn't help but think, so the Trinity is holy for humans because of the way that we reproduce, but if we were binary organisms that reproduce by binary fission, like if we were yeasts, and we were building a cosmology, would we end on the 3 or would we end on the 4? Or would we begin on the 4?
I think you need to ask some bacteria. I think you need to have a conversation.
I spent many years trying to ask them.
If anybody knows a bacteria that wants to come on the show.
Yeah.
I tell you who you should be interviewing, a slime mold.
Please.
You should.
Yes. That's a really good idea. I'm going to write that down. So, go ahead.
No.
Since we are starting to hit our time limit, there's 2 directions we can go. We can either go deeper into the holographic principle, or we can open up the topic of the purposeful evolution of the universe, which I think is what all of this sort of leads us to. And so maybe that might be a good place to close. What is the...
Yeah, I'll be happy to. I mean, it's interesting because we've had a predominant paradigm which has been devoid of meaning and bereft of any purpose, What I really was curious about is to see how the evidence that I bring together in the story of Gaia, does it show purpose? And my perspective, and I would invite every reader to come to their own perspective of this, but for me, it was very much a yes, it does. And that goes back to the very beginning, how our universe was set up, this incredible level of fine-tuning, and we can talk about parallel universes, but I'd rather us not, because I think it's a nonsense. It was a premise put forward by Everett, really, and others, really to avoid having to bring consciousness anywhere near consideration.
Yeah, I was going to mention that, where it's like it was almost like it fell out of fashion to talk about purpose. And I think that there's like a deeper sociological conversation about the role of religion and our place in the universe, and people kind of getting tired of this idea that humans are some pinnacle gods that the rest of the universe serves them. And so there was definitely this idea of humans as being the purposeful evolution of the universe, and people became allergic to the idea of purpose because they came to realize that that was kind of an arrogant and limited way of seeing everything.
I can really appreciate that. What I would say is that we're now at a position astronomically of realizing that there are probably more planets than stars in our galaxy, and that there are at least 11 million Earth-sized planets orbiting in habitable zones around their stars. So this is not a human-based perspective. This is more a perspective that we're in a fortunate position as both self-aware species and a technological species, that we can look out and look back and look small and look big, and then see what the evidence is showing us. And as a cosmologist, basically I'm just curious. I'll show up for a question. I'll show up for a why every time. But as cosmologists, we're now able to look back to the beginning of our universe to realize that it began, best estimate, 13.8 billion years ago, to realize the evidence shows in its most simple, ordered state, evidence showing us the incredible level of fine-tuning and the exactitude of the algorithms, the laws of physics. They are so exact. To look at the WMAP analysis of the cosmic microwave background to show us the flatness, the geometrical flatness of space, which is why, going back to Pythagoras and Einstein, y equals mc squared. Why those basic laws they are incredibly simple, because they fit together so purposefully. And what they do in that fitting together, that innate relationship, is they enable. They don't just allow, they enable a whole evolutionary arc from simplicity to complexity. I mean, I talk about in the story of Gaia the ways, the relationships within interstellar dust clouds before our planetary system came into being. The prevalence and the coherence of interstellar scale magnetic fields, the level of ultraviolet light, the abilities after nearly 9 billion years for primordial hydrogen to come together with water into ice, not crystals, non-crystalline ice. The getting to that point of complex prebiotic carbon-based molecules, literally before our sun and our entire solar system came into being, were all the harbingers that we now call DNA, RNA, lipids, amino acids, carbohydrates, were all in interstellar dust clouds and bathed in such a way that there was an innate chirality, a left-handedness and right-handedness even within those prebiotic molecules, that when our planetary home came into being as a water planet, facilitated the ongoing emergence of even greater complexity. So all the way through, there has been this incredible process of evolutionary emergence. And the other thing is that it's prescient. I mean, I tell the story. This is a cool one. I love this one. I always ask the question. I was asking this question when I was 9 years old, when I first found out about it. Why did our universe not just have hydrogen from the beginning? Why did it have helium? Quite a lot of helium, actually, and a little bit of beryllium and lithium, tiny amounts. Why did it have all of that helium from the get-go when it was simpler to just have hydrogen? And it's only when I looked later, much later, at the whole nucleosynthesis of elements, chemical elements within stars, that the answer came. And the reason is when you start to synthesize, alchemize hydrogen to helium, but then helium to heavier elements like carbon and onwards, you have a real problem, because there's something called the triple alpha reaction that is incredibly difficult. It's so fine-tuned. You have to get everything in alignment really quickly to jump that gap, to jump over that threshold from helium, 3 helium nuclei, to carbon. Of course, if that hadn't happened, we wouldn't be here because we're carbon beings, yeah? And all the other heavier elements wouldn't be here. And it turns out that because there was that level of primordial helium from the very beginning of our universe, hundreds of millions of years before stars formed, that there was enough helium ambient in that hydrogen-helium mix that, formed into those stars, that there was enough helium on sort of standby to ensure that that triple alpha reaction could happen. Without that being the case, it would have just shuddered to a standstill. We would not have gone beyond very simple universe. And that's happened time and time and time and time again, which I talk about or write about in the story of Gaia. So that's what I mean by purposefulness. And I think if you've got a meaningful universe, why would you have meaning without purpose? It's almost like, untangling complementarities that are fundamental.
So, with 5 minutes left, I was hoping that you could give me your perspective on something that's troubled me since I first began studying these things, which is that we've inherited a cosmology. All of these cultures, since the beginning of history at least, have embraced a cosmology with a beginning. And of course, you can reconcile the evidence with this, and this is what's increasingly being done in mathematical and empirical cosmology today. But it opens up this whole series of heartbreaks for me, which is, first of all, if there was a beginning, what did it begin from? And if it began from something, what is the story of that something? And is it really even a beginning? If you're talking, how do you make something from nothing? Or if you're not making something from nothing, what's the story of what came before?
My sense is, and I've spent my whole life with this question, and when I was 4 years old and starting to have these incredible experiences, I was experiencing reality as being far more than our universe. And of course, the ancient traditions, the mystical traditions, talk about the infinity, the infinite and eternal cosmic mind, as Einstein called it. There have been different terms throughout history. We might call it God, we might call it Allah, we might call it great mystery, great spirit, cosmic mind. But now we have better, perhaps, perception than we ever have had of the evidence that our universe is finite in terms of both space and time. So beginning 13.8 billion years ago in this minute but first moment of an ongoing big breath, and likely to come to a completion not that far ahead, maybe tens of billions of years ahead, in terms of maximum informational content, minimum temperature. But then we're talking about our universe as being a finite thought form of an infinite mind. So the question then is not how something comes from nothing, because of course when we balance out all of the, we end up with an even playing field in that regard. but it's perhaps what came before. And there is an extension to general relativity called EKS, which suggests and perhaps points to the possibility of supermassive black holes having the conditions within them that almost act like a screw into the birthing of another universe. We also have this perception of what might have come before us, and that might be that what became before us. We also have Penrose's perception of sort of cyclic cosmology. And I think that the thing is that we're still working with this. This is a work in progress big time. Some of these perspectives are sort of spatial and geometric. Some are temporal. I think they all need to understand, certainly within our universe, these three laws of infodynamics and what guidance that offers us. But for me, it's been this sense of our universe is a great thought, as James Jean said, rather than a great thing. And that we are, and this is vital, we are its microcosmic co-creators. So what I've been talking about is not a human-centered cosmology. It's a universal cosmology that pretty much, other than bacteria, possibly, but any level of individuated self-awareness and collective awareness that could come to this conversation ability would come to the same realizations, which is why the Planck constants, we can measure them in any measure, but they are essentially measureless, and they would be the same whether they're measured in our measures or measured in goodness knows what measures, another self-aware species on another planet, in another galaxy, billions of light years away and millions or billions of light years in the future, or possibly millions old. There seems to be a huge amount of universal, not just expansion, but maybe informational content acceleration about 5 billion years ago. That's when our universe, in its expansion of beginning, slowing down, began to accelerate again. And I wonder whether that's when a huge amount of emergence, of planetary emergence, and then biological emergence really continued that evolutionary arc. So I wonder whether there's loads of folks, non-human, throughout our entire galaxy and universe, having these sort of conversations.
It seems almost inevitable, because the emergence of life, I mean, obviously I'm a living creature, and so I can't help but see it this way, but it does seem like the universe has conspired to create the conditions for life, and life is meaningful. And
exactly.
and like you said, if there's meaning to the ability to look out onto the universe and to contemplate it and to ask these questions, then surely we must orient ourselves to asking, what is the purpose of our being here, in order to be able to ask these questions. And I think that we live in a time of terrible anti-human mentalities, where humans are seen as this cancer on the earth that should be, eradicated and should be minimized, and, the world would be better without humans. And this is this place of looking at life as wholly meaningful and purposeful gives one the ability to stand and to look out and to be optimistic. And I think that is so valuable, because to live as a human and to hate yourself is perhaps the most tragic thing of our entire civilization right now. It's to feel like we are a failed experiment of the universe, and that it would have been better if we had never been born is so incorrect. I don't want to say, actually wrong, right? Because incorrect is about facts and wrong is about morality. And I think that the moral thing to do is to see it as something that grows and develops, and that we can nurture it into the future. And so thank you. Thank you for that perspective. Thank you for giving us a different place to stand, to look out onto the universe.
Thank you for this. It's been wonderful. I just come back at you with that. It sounds as though you have a little one running around the studio at times.
She's a cat right now, but we're working on that.
She's cat. Okay. She's a cat causing chaos. Okay. But you love her. Yeah. You wouldn't say she's meaningless. You wouldn't say she's a mistake.
Yeah.
We are not a mistake. What we have been on is a journey of individuated self-awareness. That's taken us this far. It cannot take us any further. Just as, a 3-year-old cat or a 3-year-old child grows up, it seems to me that this is our opportunity to grow up as a species.
Yeah.
To expand our spiral of compassion, as Einstein said, from the me to include the we and the all. And what I've been sharing tonight is the evidence that we are inseparable. We are unity in radical diversity, but we all belong. We all belong to each other, our planetary home, and the entire universe. For us to wake up to that now, because we really need to, I just feel an incredible opportunity and potential and an invitation from our universe and from our planetary home to grow up to become their co-evolutionary partners. That is what I feel our opportunity is, and the invitation to us is at this moment.
It's beautiful.
Love it.
Thank you so much.
You're very, very welcome. Thank you both so much.
Have a wonderful night. Dr. Currivan, that was wonderful. Thank you.
Jude, please. And
Jude, that's right.
Thank
That's
you
right.
so much.
We'll mention your books in the introduction, and we'll put the links in the description so people can find them. Thank you again for sending them to us. I really valued how you put the whole story out. Like it's such a clarity of thought and a clarity of tale that I really appreciated it.
Thank you both so, so much. And lots of love to you both. And thank you for your wonderful work. This is really, really important that you're doing this.
Thank you.
Okay.
Good night.
Good night.
Good night. Thanks again. Good
Bye.
night.